All right, your book should be open up to this page, 524. We're going to go over as much as we can get done in the time we have left, not that we're passing away, but the time we have left in class. Not the time we have left in life, the time we have left in class. I don't want to record until I've had that be a long video. All right. So I had questions on this from students, which is kind of silly, because if you read it, the number pattern below follows the rule y equals x plus 3. That's important. Where y is the number of squares and x is the figure number. If you didn't know what a figure was, it's written right here what a figure is. I'm just saying. Find out how many squares will be in figure 5. And then display the pattern in the coordinate grid. Coordinate grid's down below. All right, so what would the ordered pair be for figure 1? 1, 4. Because the x-coordinate is, where to say that? The x-coordinate is the figure number. The y-coordinate is the number of squares. Now, which is easy because you could just count them, or you can follow the rule. X plus 3 equals y. Figure 2. What's the x on figure 2? 2. Because the x is the figure number. And the y on figure 2, class? 5. Figure 3. What is the x? 3. And what is the y? 6. Okay, so the pattern, the number of squares is 4, 5, 6. What would be next? 7, 8. And the ordered pairs, we have 1, 4. We have 2, 5. What's our next ordered pair?
3, 6.
Next?
4, 7.
Next?
5, 8.
Okay, so we get these ordered pairs. Then we're going to graph them on the coordinate graph below. So let me slide that up a little bit. And then we're going to graph them on the coordinate graph below. Can you what? No, because I'm recording. Alright, so hopefully we're following along, because the test we take on Friday, this might be something that's helpful for you. Alright, so we're going to plot the ordered pairs on the graph. What does the x-axis going to stand for? What information is the x-axis going to stand for? Is it going to be the figure? Is it going to be the number of squares? The figure. And the y-axis? Number of squares. Now, when we're doing this, how did we get from figure to the number of squares? What was the rule? X plus 3. That's called an additive pattern. An additive pattern, which means you're adding to get from the x to the y. You might see problems that say, what kind of pattern is it? And then what's the rule? Additive is adding. Multiplicative is multiplying. So if you just think of it that way, additive, adding, multiplicative is multiplying. Last year the test had a question. What kind of pattern is it? And people freaked out. Andrew?
Is there subtracting?
Not that we have to know this year. Okay? Alright, so my first ordered pair is what? Let's go, Hannah. 1, 4. My second ordered pair is what, Preston? 2, 5? Which is halfway between 4 and 6. Many people yesterday freaked out when they saw the Mockingjay practice one. They're like, I don't know, there's numbers and a half and
decimals.
decimals, and then they were crying. All right, so my next one is 3 what? Anna. 3 6. And 4 what, Jesse?
4 7.
4 7. 4 7. Now you'll notice. Did we do 5? No. Okay, so you'll notice if you do something specific to the x to get the y, if you have a rule to go from x to y, you're going to notice it's going to complete a straight line. Taylor, you got a question? Never mind, Taylor doesn't have a question. For those of you watching at home, Taylor doesn't have a question.
My name's not Taylor, it's Abigail.
Oh, okay. Abigail doesn't have a question either. All right, so let's move this up. Okay, in this question, these two are really easy. Still had questions because people didn't read them. We multiply, and I know it's bright light shining here, but there's not a whole lot I can do about that. We multiply the number of nickels by 5. Number of nickels by 5, which means we multiply them to find the number of pennies. The input is what? Nickels. The output is what?
Pennies.
What kind of pattern is it? Additive or multiplicative?
Multiplicative.
So what would the rule be? X times 5 equals the pennies. X times 5 equals the pennies. So Renaya, 3 nickels is how many pennies? 15. Oh, let's go. Andrew, 4 nickels is how many pennies? 20. Okay, so these are our ordered pairs. Our ordered pairs are going to be 1 5, 2 10, 3 15, and 4 20. And it says we need to complete the pattern, display it on the coordinate grid. It's awesome when you read directions. It tells you what to do.
It's awesome.
Okay, so we have 1 5. We have 2 10. We have 3 15 and 4 20. So if it gives us a rule to get from input to output, it's always going to form a line. Now what you might see on a test is if they gave you this and asked you which graph you would see. I can tell you 3 of the 4 answers they would show you. 1, they're going to show you the correct graph. 2, they're going to show you the graph backwards, where you do the y first and the x, and that would be wrong. 3, they're going to show you one graph that's not a straight line. Immediately, you can eliminate the not a straight line graph.
Yep.
And then you can look and see which one's backwards. And it's going to be one of those 2. Okay, here. We add 5 to the input. So it's what kind of pattern? Additive. An additive pattern. So it's going to be x, which is the input, plus 5. That would be my rule. X plus 5. So the input's 1, the output is, class?
6.
6. The input's 2, the output is? The input's 3, the output is? The input's 4, the output is?
9.
The input is 10, the output is?
16. 15.
15. It doesn't matter what, if you have the rule, it doesn't matter what the input is, you should always be able to figure out the output. I could put 36 here. I could put 1,287,000 here. And all you have to do is add 5 to get to the output. Okay, so let's graph this. We go 1 over, 6 up. We go 2 over, 7 up.
7 up.
3 over 8 up. 4 over 9 up. 10 over 15 up, which is not going to be there.
Nope.
Okay? It doesn't matter if you know the rule, which here's x plus 5. You should be able to fill out the input table and then be able to graph it. Again, since we have a rule to go from input to output, it's going to form what would be a straight line if it was connected. Questions on those two? All right, let's move on. Rocky, are you following along? Okay. Are you getting them all right, Rocky?
Yes. Oh, no.
Oh, so you guys are both Rocky? All right. This question, actually very easy because it tells you in the question what the answer is. It tells you in the question what the answer is. The rule for a pattern is add 4. So what kind of pattern is it? Additive. Add 4 to the input. Explain how you can use the rule to write the ordered pair. So how would I use the rule to write the ordered pair? Add 4 to the input. Okay? Very easy. Add 4 to the input. We add 4 to the input. Piece of cake. Add 4 to the input. That's all you had to write on that. Very simple. Very simple. Please don't shake the chair. Yes, ma'am.
So you should why does it say hot?
Because it's hot means you should know it.
Okay. What does hot mean? Higher order thing. What?
All right. Question 4. Question 4. Write 5 ordered pairs to represent the pattern rule. Multiply the input by 3. Display the pattern in the coordinate grid to the right. Okay? So we have our input. We have our output. How should we just go 1, 2, 3, 4, 5?
No.
No? Let's go
3, 6, 9.
2, 3, 5,
8, 9, 4.
1, 4. Okay? So if the input's 2, the output is 6. The input's 3, the output is 9. The input's 5, the output is
15.
the input's 1, the output is
3.
the input's 4, the output is
12.
Again, if they're giving you the rule, when I graph this, it should be a straight line. If they're giving us the rule. It says to graph it 2, 6, so I'm going to go by 2s here. 2, 4, 6, 8, 10, 12, 14, 16, 18. I'll do the same here because you want the same intervals on the horizontal, on the X and the Y. 2, 4, 6, 8, 10, 12, 14, 16. All right, so my first order pair is 2, 6. 2 over, 6 up, very easily. Okay? Realize, and this freaked people out yesterday, there's no 1, there's no 3. Well, it's going to be halfway between 0 and 2. Halfway between 0 and 2. My next ordered pair is 3, 9, which falls right between 2 and 4. Go up, and 9 is between 8 and 10. Then we have 5 and 15. Oh, no, 5. 5 is between 4 and 6. Up, 15 is between 16 and 14. We have 1, 3. 1 over 3 up. And we have 4, 12. 4 over 12 up. Just remember, like I said yesterday, you walk before you get in the elevator. You walk before you get in the elevator. So it's horizontal, then vertical. Horizontal, then vertical. Questions on these? Awesome. This is really easy. And as I said before, the questions on the test we take on Friday, all of them are coming from Unit 14. All of them. Every last one of them. They are. Stop arguing, Savannah.
Yeah, Savannah. So when you're waiting, don't need to argue. You don't need to argue. Yeah.
All right. Quiet. All right. Use the coordinate plane for 5 through 7. Emily has a road map with a key that shows an inch on the map equals 5 miles of actual distance. Use the table and the coordinate grid to show the pattern. So what did it say? 1 inch equals how many miles? 5. 2 inches is going to equal 10. So what's my rule?
5. Input times 5.
Input times 5.
X times it goes down. Output.
Or x times 5.
Yeah.
3 is going to be what?
15.
4 is going to be what? 5 is going to be what?
25.
Again, it worked every time. X times 5, x times 5, x times 5, x times 5, x times 5. So this should form a straight line. Additive or multiplicative?
Multiplicative.
Multiplicative, because we're multiplying. Then it says use the table of the coordinate grid to show that we have to plot it. What is the actual distance on the map? If it was 6 inches, 6 inches, what would be the actual distance? 30. Plot, write the order pair. Plot a point in the coordinate grid to show the appropriate order of pair. So we have 1, 5, 2, 10, 3, 15, 4, 20, 5, 25, 6, 30. And again, it gives us a rule, so it's going to form like a straight line. Gives us a rule, so it'll form a straight line.
Yay.
Yeah, and we plotted it. So it would be 2 questions. The actual distance on the map is 6 inches. Okay, what is the actual distance? Would be 30. So you'd have to put 30 inches. And then we plot, write the ordered pair. My ordered pair would be 6, 30. My answer would be 30 inches. No, 30 miles, sorry. So both of those would have to be written. Then we have to plot all this to show the pattern. Again, we have a rule, so my pattern is going to be straight. We have a rule, so the pattern is going to be straight. Why do you look guilty? Okay. So hopefully you have these, because you stole something, I guess. Tape. All right. Oh, now this is a good question. All right, so this one, and we don't have our input-output table together, but input was map in inches. Output was actual miles. And we had 1, 5, 2, 10, 3, 15, 4, 20, 5, 25, 6, 30. All right, now this one's asking something different. What is the distance on the map if the actual distance is 45 miles? So it gives you the y, but it wants you to find the x. It gives you the y, but it wants you to find the x. And then we'd have to go up there and plot it, but I'm not going to do that right now because I'd have to move it back down. Hannah, what would be my map inches? 9. The map inches would be 9. if the actual miles is 45. And how did you figure that out, Hannah? You did 45 divided by 9, or 45 divided by 5 equals 9. Fact families. 9 times 5 is 45. The fact family 45 divided by 5 is 9. So just think fact families that you learned when you were tiny little lads and laddises. Young men. All right. I know, it's like time. I want to do one of these. Ted, not right now, I'm teaching. Ted gets $10 allowance every week and saves $6 of it. He makes a graph to show his savings, where the x-coordinate represents the number of weeks. So the x-coordinate is the number of weeks, and the y-coordinate is the number of dollars saved. Okay, so the x-coordinate is the number of weeks. And this is the amount saved. Okay, so if I make my own input-output table, it's going to make my life easier. Okay? So every week he saves $6. So week 1 he saves how much? 6. And we're looking for which one of these could be on the graph. Do we see 1 6? No. 2 12s. 2 12 up there? 3
18.
4 5 6. Any of these up here yet?
Yeah.
636. But notice like I've said 100 times, they're going to put the opposite one up there every time. And if you slow down and don't realize you walk before you get in the elevator, or horizontal before vertical, then some of you are just going to pick that because you did it backwards. Questions?
No.
All right, flex time. We'll go over the last 3 of these at a later date. Love y'all.